The following content is created by DrAvitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below.
Welcome, ladies and gentlemen. In this video, we're going to be solving this very problem. So it says find the half-range sine series for that very function. Now, since we're asked to find the sine series, it means we're dealing with the odd extension. So we're going to be treating that function as an odd function. So we only need to find b sub n, and b sub n is 2 over L, since it's an odd function, 2 over L, integral from 0 to L, f of x sine n pi x over L dx. So that's going to be the formula. Now, what's L? L is half the period. And since the range has been halved already, so L is just 1. L is just 1 because they've already taken the half. Don't need for us to take the half again because L is half period. They've taken the half already, so that's just 1. So this will be 2 over 1. That's 2 over 1. Integral from 0 to 1. F of x is 1. F of x is 1. So f of x is 1 sine. If L is 1, if your L is 1, anything over 1 is that same thing. So this will be n pi x dx. So this is what we have. Now 2 over 1 is just 2. So this will be 2 integral from 0 to 1 sine n pi x dx. So this is 2. Now if you integrate sine, you will get minus cosine. So this is minus cos n pi x over, when you differentiate this bracket, you will get n pi. So this is n pi. And this is from 0 to 1. Beautiful. Now, the minus is a constant. The n pi is also a constant. So let's bring it outside. This is minus 2 over n pi. And then what will be left is going to become cosine of n pi x from 0 to 1. Now, anywhere we see x, anywhere you see x, we're going to be putting 1. So this will be minus 2 over n pi. Then let s be 1. So this will be cos n pi minus, next, s is 0. So this will be cos 0. Because n pi times 0 is just 0. Okay, now this is minus 2 over n pi. Cosine of n pi has a special value, which is minus 1 to the power of n, minus cos 0. Cos 0 is 1. Now, this particular bracket, if you've been following this series, has a particular behavior. It has a particular behavior. Now, what we're going to do is, when n is odd, this will then mean our b sub n is minus 2 over n pi into, let's pick 1 for example, because 1 is odd. So minus 1 to the power of 1 is what? Minus 1. And then you have your minus 1. So this will be minus 2 over n pi into minus 1 is minus 2. So together, minus 2 times minus 2 will give us 4. So this will be 4 over n pi. So this is your b sub n when n is odd. Let's see when n is even. So b sub n will become minus 2 over n pi. Now, this bracket, let's pick 2 because 2 is even. Minus 1 squared is 1. So you have 1 minus 1. So this is minus 2 over n pi. Then minus 1 minus 1 is 0. So everything here will just be 0. So this means that when n is even. So this means that when n is even, our b sub n will be 0. Then when n is odd, our b sub n is 4 over n pi. Now with this, we can find our Fourier series for that very function. So f of x is the sum from n equal to 1 to infinity of b sub n sine n pi x. Normally, I would have said over L, right? But since L is 1, let's just skip that because anything over 1 is that same thing. So this will be the sum from n equal to 1 to infinity. B sub n is this value, 4 over n pi sine n pi x. You could put a bracket if you wish. So this is your answer to the equation. But there's a problem. This item here means n must be odd, because remember, when n is even, you have 0. So this is when n is what? Odd. You might forget. So sometimes you might want to include comma odd, even though the summation function does not have a comma part of it. So comma odd. Now let's write out some terms here. Let's write out some terms. But before then, 4 over pi is a constant. So bring it out. So this will be 4 over pi. Then the sum from n equal to 1 to infinity. What will be left to become 1 over n. The 4 is outside already. There must be something at the numerator. So that's 1. Over the pi is out, so n is left. Sine n pi x. So this is what we have. Also keep it at the back of your mind that n is odd. So this is 4 over pi. Let's list out some terms. So let n become 1. So this just becomes sine pi x when n is 1, because you have 1 over 1 sine 1 pi x. But 1 times anything is that same thing. So this will just be sine pi x. Plus when n is 2, this will be 1 over 2 sine 2 pi x. When n is 3, 1 over 3. Oh, you see, I've just made the same mistake where I said n has to be odd. But as you can see, I've gone to put in 2. But n is not supposed to be 2, because when it's 2, it's even. So there should be no term like this. So this term should instead become 3, 1 over 3. Then next, 1 over 5 sine 5 pi x. And just like that. Okay, now as you can see, I said you might make a mistake if you're not very careful, if you do not remember that n is odd. Now there's a better way to write this. The best way to write this in such a way that all n values become odd is to make the replacement. Replace n with 2n minus 1. When you replace n with 2n minus 1, every single number you get becomes odd. So we could say that f of x is equal 4 over pi with the sum from n equal to 1 to infinity. Now this will become 1 over, the n here becomes 2n minus 1. Then sine, the n here becomes 2n minus 1 pi x. Now with this, every single value you get becomes odd. So this will be the answer in terms of n. If they say in the nth term, leave your answer. This is the answer in the nth term. Then this is the answer when you expand it to contain at least 3 non-zero harmonics. So this is what you have. Now with this, we're going to end this very video. I'll see you in the next one.